Okay, this is Richard Hall here from Stonehenge, Aotearoa, and looking at our wonderful night sky. Always, first of all, I'd like to sort of thank Dan Broughton of Wairarapa Web Design, who sponsors this program. And we've just had, of course, Star Date out at Stonehenge, and it's been a very busy time with live music and so on. And of course, we had lots of viewing of the night sky, the stars, and various programs like that. Well, I guess after the talks on that, when everything was dark, we took people out to have a look at the night sky. And I'm going to do a little bit of what some of the things we took people around to have a look at when we were out there at Stonehenge. Okay, so I thought I'd call the little talk we're going to do today, well, it's going to be the realm of the giant, all right? Because once the sun sets, all right, and stars gradually begin to appear, perhaps as we're looking towards the north, one of the most well-known constellations appears in the sky. And this, of course, is Orion the Hunter. All right, and always got to remember when you're looking at constellations that they appear upside down, but you can't really miss it. It's I guess in New Zealand people often call this the pot. Right, and you've got those three bright stars in a row, and then around the pot are the several other very bright stars, and they're all part of the constellation of Orion. Now, the bottom of the pot, as it were, which is the belt of Orion, is particularly important because it marks what we call the celestial equator. And consequently, those stars always rise absolutely due east and set absolutely due west. All right? So that's a really important navigational marker itself. So these stars, but it also means that Orion is visible from both the northern and the southern hemisphere. All right? But that's because it lays across the celestial equator. And to us in New Zealand, or Australia for that matter, well, we would say it's our summer sign of summer. But of course, back in the northern hemisphere in America, Europe, Britain and so on, it's actually the sign of winter. Going out is your winter star sign. Anyway, the important thing is about the stars that we've got out there, is that when we look at the big bright stars in the sky, we're not looking at the common or garden variety of star, as it were. All right. This is the reason for this is that well, I guess it's when if you're driving along the paddock and you look out across a paddock and you can see all these big bright stars. You can see all these animals. First thing you notice is the cattle. And there's possibly the sheep, but your eyes miss the millions of other smaller creatures like mice and insects and that are out there as well, all right? And, it's exactly the same as when we look at the night sky. So when you look at a star, you can't necessarily tell whether a star is bright because it's close to us or it's bright because it is intrinsically bright. And stars themselves vary enormously in brightness. Our sun, of course, is a star. And the brightest of stars are up to 1 million times brighter. Well, at the other end of this scale, we've got stars which are 1 million times fainter than the sun. Right? But when we look up at Orion, we really are looking at these big bright stars. These are giant stars, and the brightest star in Orion is Rigel. Right? And it's in the upper left from where the bottom of the pot is. It's a bluey white star, all right? And it is truly a great distance away. If you take the nearest star to us beyond the sun is Alpha Centauri. It's just over 4 light years away. But here we've got Rigel. It's 773 light years away, all right? And the same with all the other stars out there in Orion. They're all at great distances from us. Now, the very fact that you can see a star that's 700 light years away, well, that's telling you something. It's telling you that it is indeed really bright, and which indeed Orion is. A colossal absolutely bright star. Seen through a telescope, it's quite noticeable that there is a sort of looks like a little cloud close to Orion. This is actually dust and gas, and it is actually what we call the Witch Head Nebula there. Right? But anyway, if you were to stand on the surface of the Earth and you had Rigel as the sun, well, you'd rapidly vaporise. In fact, even Pluto would vaporise from if you had Rigel as a sun. The star is actually 66,000 times brighter than the sun, right? And it's a white hot star. And most of that radiation it is being given off is actually in the blue end of the spectrum. So the colours on the planets would look very, very different than they are here, because there'd be quite an emphasis on blue light there. Right? So that's Rigel. Now Rigel is the brightest star in the constellation of Orion, but it's not actually the biggest, because stars also vary in size. And if you look at Betelgeuse, and you can all remember Betelgeuse from the I guess that movie Beetlejuice, they actually calls them, right? But that's because it's a red star, and red stars in the ancient world was associated with demons and things like that, you see. And particularly stars like Betelgeuse, which actually slowly fluctuate in brightness. Now, Betelgeuse is actually a lot closer to the sun than Rigel is. It's just 427 light years away. I say only, but that's an enormous distance. And but this star is so large that the Hubble Space Telescope is actually able to photograph it. So instead of it just appearing as a point of light, we actually see it as a star itself. And it doesn't look very much like our sun at all. If you could imagine our sun being replaced by Betelgeuse, well, it's so big that we'd actually be inside it. In fact, the surface of the star would be roughly where the asteroid belt is. It's an absolutely colossal star, all right? It's got a diameter 936 times bigger than that of the sun. To give you a good idea what it is. And its actual brightness is 10,500 times the sun. But Betelgeuse is a red star. You see, its surface area doesn't pump out quite so much light, so it's quite a reddish star. And it's a star that's nearing the end of its life. It would have been a star like Rigel once, but then as it began to run out of nuclear energy, it's puffed up and turned into this giant red, what we call a red supergiant star. So that's Betelgeuse up in our sky up there. Then we've got, of course, lots of most of the other stars in Orion. They're all blue-white stars, all extremely hot. The belt itself, if you can have a look at it through a large telescope or you photograph it, you find that these bright stars are sitting in front of what is an enormous dark cloud. You see, in addition to stars out there and planets which orbit around stars, in between the stars is dust and gas. And here and there, this dust and gas collects into vast clouds. And these clouds are actually the raw material from which new stars and planets are actually formed. And the bright stars of Orion lying in front of one of these big stars. Now, seen through a telescope or photograph, parts of the cloud get illuminated by the big bright stars around them. One of the most famous, of course, is the Horsehead Nebula. And the Horsehead itself is just simply a dark column of gas rising up about 3 light years. It's about the distance between here and our next nearest star. All right, but you've got to remember the Horsehead is about 1,000 light years away, and it's like a mesoid, a desert. All the gas and dust around it's being eroded by the intense radiation from the stars, but the Horsehead is like a column that is denser and it's taken longer to actually evaporate, as it were. But we can see all around there glowing patches. Now, astronomers use the term nebulae in the sky, A nebula is actually just another name for clouds. Well, there's 3 types of clouds that we can see up in the night sky, or up out in the galaxy. There are the dark clouds, right? They're just the dust and gas, which is laying out there. And we notice that normally only because where there's big patches of it, they blot out the light of more distant stars. So a bit like the coal sack in the Southern Cross, it's just a dark cloud. And that's the only time you notice it is when they're blotting out the light of other stars. Then there's what we call reflection nebula. This is when you've got a big bright star in the vicinity, and this big bright star is illuminating the cloud, all right? And when that happens, it reflects the light. So if it was near Betelgeuse, if it had a cloud around it, the cloud would be reddish in colour. If it was near one of the other big bright stars, well, it would appear bluish in colour. But then we've got other clouds which appear to be a mosaic of absolutely beautiful colours, and they're the most noticeable in the sky. Now, leading off from the 3 bright stars, above the 3 bright stars in our sky is the Sword of Orion. That's what we call the handle of the pot. And with the unaided eye, you can see a glowing patch of light. Seen through large telescopes, this whole region from just about covering the whole of Orion, but particularly from the 3 bright stars in the belt up to this, the handle of the Orion, is a star-forming region. Because, as I said earlier, this material is the stuff from which stars are born from. And normally we can't see the birth of stars because it incurs inside. They sort of hatch out in those dark clouds as they contract. But what we have in the Sword of Orion is a great nebula called the Orion Nebula. And what's happened is here we've got a cluster of new stars which has formed, and it's near the surface of the dark cloud, and this has burst. And so we're actually able to look into this crater and see what's actually there. So this is the Great Nebula in Orion. And look, folks, you can see this with the unaided eye on a clear, dark night. A pair of binoculars will show it to you, but as seen through a large telescope, it's absolutely magnificent. And you've always got to try and imagine when you're looking at these things that you are seeing things in 3D. Looking through different wave bands, infrared and so on, used by large telescopes or cameras, or space probes and so on, we notice that in the darkness beneath there is a whole chain of stars running for hundreds upon hundreds of light years of brand new stars forming out there. And if we can pop in, if we look at it, it's like the stars at the centre are these ferociously hot blue-white stars. They don't appear as bright as Rigel, although these stars are actually throwing out more light than Rigel. The reason why they don't appear so bright is that they are so hot that most of their radiation is in the form of ultraviolet radiation, but it's this ultraviolet radiation which is causing the surrounding gas to glow. Now, this crater, looking at this, it's actually a crater in the cloud. We're looking at something which is about 30 light years across, all right? And then down at the bottom there are these bright stars which have just formed. Now, if you look even through a small telescope, you can see a little group of 4 bright stars which are known as the trapezium, all right? And the trapezium itself is 4 stars. These are these 4 super bright stars. But when you have a closer look, or you look at photographs and so on, you can see that they're simply the brightest of a whole host of other stars. You see, stars are never formed on their own. When stars are born, they are born in clusters, hundreds and hundreds of stars at a time. And they will all be of different masses, and the big, more massive objects, they're the big bright ones, and the smaller the mass, the fainter a star is. Our own sun, for example, if it was twice as massive as it is now it wouldn't be just twice as bright, it would actually be 16 times brighter than it is at the moment, right? And for this reason, bright stars don't last very long. They burn themselves out. While fainter stars like our sun, they carry on burning for billions of years. And of course, there's little tiny, the most common star in the galaxy, which are what we call red dwarfs, there is not one that can be seen without a telescope, and they're going to be burning for billions and billions of years after the sun's gone. But the interesting thing is that when we look in the Orion Nebula, particularly with the Hubble Space Telescope, as these bright stars have blasted this hole inside the nebula, what has happened is that they're uncovering other smaller stars in the process of forming. And what we've been able to do for the very first time is actually see new planetary systems in the process of forming. You see, we believe planets are simply the byproduct of star formation, so that every star in the galaxy is going to have its own system of worlds. These are all theories, but right now, when we're looking into the Orion Nebula, we're actually able to see this, right? And we actually see these little disks of matter where these new planetary systems are actually forming. So Orion is our sort of showcase, but I always like to use Orion as what we call a signpost in the sky, because these stars, it's so noticeable. You can then use these bright stars of Orion to pick out other bright stars in our sky. So let's sort of have them think about that as well. All right. Okay. If we come down from Orion, all right, from that belt, as it were, and we travel through, first of all we hit another bright star, and there's a V of stars there which we call the Hyades. And if we carry on in this straight line, so we're going down bottom and to the left, we come to a cluster of stars, is the Pleiades star cluster. And incidentally, all the way along the Milky Way we will find lots of star clusters, and this is because stars, as I mentioned earlier, are formed in clusters. What happens with the passage of time? These clusters gradually disintegrate. Our own star, our sun, would have been part of a cluster. But out there, that cluster's disintegrated billions of years ago, but somewhere out there are all our brothers and sisters, as it were, both in stars and planets. Incidentally, just recently, they think they identified one of our brothers or sisters out there, another star about 30 light years away, because it has virtually the identical chemical composition to the sun. Anyway, the Pleiades, of course, again, and if you see a cluster, you know they're young, all right, because star clusters disintegrate with time. And the Pleiades, of course, is perhaps the most famous star cluster in the sky. They're both the Hyades and the Pleiades are part of the great constellation of Taurus, the bull, and the Pleiades are the tip of the bull's tail. All right, and we know the Pleiades, I guess, down here in New Zealand as Matariki, right? And but those stars have been important to people around the world because what happened was 4,000 years ago, when these stars rose up in the dawn, they marked this time of the spring equinox, which marked the beginning of the year for all the peoples of Europe and Asia. So they were known as the Pleiades to the Greeks. They were also known, if we go to the east, to expand that, we're known as Subaru, as a Subaru car. And of course down here, Matariki. Now that tradition of beginning the year with the rising of those stars was carried into the Pacific by the Polynesians. So to this day, down here in Aotearoa, we talk of the rising of the Pleiades, or Matariki, heralding the beginning of the Maori New Year. Pleiades have always been a very important stars to me, because when I first became interested in astronomy, I started studying what we call variable stars. Fortunately for us, our sun is a very stable star, and if it wasn't, we wouldn't be here. But a lot of the stars out there are variable. They're variable often when they're first formed, or later when they become really aged. And one of the stars I studied was one of the Seven Sisters, which is called Pleione. And Pleione is spinning so fast on its axis that it's not a circular, a spherical star like our sun. It's like a disk, and it's just almost at the point of disintegration. And indeed, matter is flowing out in a disk from there which fluctuates in brightness. It may well be, astronomers now think, that this was originally a twin sun with two stars orbiting around each other closely together. But what has happened is, with time, the two stars have merged together, and that's what gives this enormous spin to Pleione. So Pleione was a very important star to me when I observed it. Its distance is 392 light years. It's 190 times brighter than our own sun. So nothing compared with Rigel, as it were, but this is still a pretty bright star. Right? It was 190 times brighter. Okay, so that's that. But let's come back about to the Hyades, and I said there's this V of stars, but what is most noticeable is a bright orangey red star, all right, and that orangey red star is Aldebaran, all right, and that's the eye of the bull. Well, the Hyades are about 160 light years away. Aldebaran is actually closer, so it's just a foreground star laying in the front of the other stars. It's 65 light years away, and it is what we call a red giant. It is what our sun's going to be when billions of years in the future, when energy begins to run out. Our sun will expand into a red giant, and this is what it would look like. Of course, by that time, we will all be gone, because Aldebaran, which once upon a time would have been similar to the sun, is now 425 times brighter. So in other words, the Earth will be totally incinerated. But don't worry about it. That's not going to happen for about another 4 billion years at this particular stage. So that's Aldebaran, the eye of the bull, up there in Taurus the bull. So you've got the tail and the eye, which is Aldebaran. The tail, which is Pleiades, and the eye, of course, which is the eye of the bull there, where the V is, and that, of course, marks out the head of the bull itself. Well, now, if we go in the opposite direction, up away from there, along the belt, going upwards and up and to the right, we come to the brightest star in the sky. And it is the brightest true star. Anything that ever appears like a star that's brighter than this star is no star. It'll be a planet. This bright star is the star Sirius. Now, we don't have any bright planets in the evening sky at the moment, so it's dead easy to pick. And Sirius, however, is a nearby star. It's the brightest star in the constellation Canis Major, the Great Dog. All right, and it's a ferociously hot star. All right, it's only just over 8 light years away, 8.6 light years. It's 25 times brighter than the sun. It is the brightest star in our region of the sky, all right? But and it's got a mass of about twice that of our own sun, all right? But the interesting thing is that way back in the 19th century, when astronomers were observing Sirius, they noticed as it was moving through space, it was wobbling. Now, stars don't wobble. Our sun, for example, and other stars tend to move in a straight line through space. Something was causing this star to wobble, and eventually it was discovered there is another star. So Sirius is not just a single sun, it is a twin sun. The smaller star is roughly the same temperature, but it's over 400 times fainter. And they call this, while the big bright star is often called the dog star, they call this one the pup, right? The little one. And, well, you see what will happen. I mentioned a little bit earlier about Aldebaran being a red giant, and in the final stages of its life, our sun will be a red giant. But eventually, that outer envelope, as the star begins to die, the outer envelope of red gas will be hurled off into space, and all that will be left is the core. And that's exactly what we're looking at here with the pup. Once upon a time, that star was bigger and brighter than Sirius itself, but it's run for its life, and all that's left here is this core. And the core is very, very small, all right? It's about the same size as the Earth, all right? But it's got the same temperature, and it's got more mass in there than the entire solar system. So this is more massive than the sun, but it's about the size of the Earth. And this is the corpse of that star that once existed. And all it is doing now is slowly cooling, and with time it will become cold and dark. But the really fascinating thing about it is that the whole, if we listen to it with radio telescopes, we can hear this tinkling noise, because literally as this star cools down, it is crystallizing, turning into a large crystal. And the interesting thing about it, right? The interesting thing about it, when we look at this crystal, as it were, you've got to remember that it's made mostly of carbon, right? So what's it turning into? It is turning into a gigantic diamond in the sky, but a diamond the size of the Earth, right? So this is this big diamond out there. Now it's ferociously hot at the moment. It has a temperature of about 10,000 degrees, but it's gradually cooling away. However, don't ever imagine that in the future that you would actually be able to mine this thing or go and take a piece of this diamond, because what I remember what I said earlier. It has the same mass of the solar system, compressed into this object the size of the Earth, right? So if you were to land on the surface of this object, you would have the uncomfortable feeling of weighing something in the region of 10,000 tons, and your body would collapse faster than the eye could see, and your body would be spread over there an area the size of a football field. So these white dwarfs, these diamonds in the sky, we can observe from a distance, but we will never ever be able to land, as it were, on them. All right. So they're something that could be admired only. Never been able to get that closer to them. So they're quite a object. And incidentally, when I say about the same size as the Earth, it's actually slightly smaller than the Earth. All right. Anyway. So that is the bright star Sirius in the sky, and if we go out from a line from Betelgeuse straight out in a line, you come to another bright star, and that's called Procyon. All right, and Procyon, Sirius, and Betelgeuse form what we call the summer triangle. Now there are three bright stars rather. All right, see if you can pick them out tonight if they're clear. All right. That's Sirius, the bright one, Betelgeuse, the red star, and then to the right is Procyon, right? So these three bright stars form our summer triangle. Of course, if you live in the northern hemisphere, it's called the winter triangle. Oh, Procyon is another nearby star, okay? Nowhere near as bright as Sirius. It's just 11 light years away, right? It's nearly 8 times brighter than the sun. But it too, just like Sirius, has a white dwarf companion. So again here we have a situation where once upon a time there was a much bigger bright star out there long, long ago. Well, I guess I haven't taken you, I've only just taken you around a small number of the bright stars in the sky at the moment. I think we're just about running out of time, right? Anyway, what I'm going to do now is I'm going to be quiet for a little while, and maybe next month I can carry on and show you some of the other wonders which are just below Orion. Good night.